You might be asked questions about tangents to polar curves, which will require the first derivative of polar functions. To begin with, we know that x is defined as r cosine theta, and you just need to remember that r is a function of theta, as indicated up above. The same thing with y. Remember, y equals r sine theta in polar, and r is a function of theta. We will use a similar derivative as parametric. We will take dy d theta divided by dx d theta. When I go dy d theta and I want to take the derivative, I'm actually taking the derivative of two functions being multiplied together. So I have to do product rule here. If I do derivative of the first times the second, would be dr d theta times sine theta, plus derivative of the second times the first. You'll get r cosine theta. So that's dy d theta. Now look at dx d theta. Again, I'll have to do product rule. I will do derivative of the first times the second. So that's dr d theta cosine theta, plus derivative of the second times the first. So the derivative of the second is negative sine theta. So we have to remember that. Now put those two pieces in the formula. This one goes in the numerator, dy d theta, and this one goes in the denominator, dx d theta. So that's our formula. That's where it comes from. We'll use number 74 from the book. Find the slope of the tangent line to the graph of r equals cosine theta over 3. What I'll need from this information is dr d theta. So I'll start with getting dr d theta, and that will be negative 1/3 sine of theta over 3. I'm going to use dr d theta in the formula for derivative up above. Here we go. dy dx is, in the numerator, we have dr d theta, which we just calculated, is negative 1/3 sine of theta over 3. Multiply that by sine plus r times cosine theta. Now, r was given to us. It is cosine of theta over 3. Multiply that times cosine. Now, the denominator, dr d theta, is negative 1/3 sine of theta over 3. Multiply by cosine theta from the formula up above, minus r is cosine of theta over 3 times sine theta. Now, this expression, if it were easy to simplify, we could do that next. But we have two types of angles here. We have a theta over 3 angle and we have a theta angle. So perhaps just evaluating at this point would be the most efficient next step. Let's evaluate at theta equals pi. Substituting pi in for all of the thetas. In the numerator, the first parentheses will be negative 1/3 times root 3 over 2, and then the sine of pi is 0. The cosine of pi over 3 is 1/2, and the cosine of pi is negative 1. In the denominator, I'll have negative 1/3 times root 3 over 2 again, but this time I have to evaluate the cosine of pi, so that's negative 1, minus the cosine of pi over 3 is 1/2, and the sine of pi is 0. We have two terms that are going to 0, so in the numerator this term and the denominator that term. In the numerator we have negative 1/2, and in the denominator we have root 3 over 6. So if I rewrite that as negative 1/2 times the reciprocal, I can see the 2 and 6 will cancel. This is negative 3 over root 3, and when I rationalize the denominator, I get negative root 3 as my answer. Please go to the next example, number 76 from the book, and work that problem out on your own, and then turn the video back on to check your work. So go ahead and pause the video now. Remember to start by finding dr d theta. That will be negative 2 sine theta. And now I'll set up dy dx. It will be that fraction, and we will enter dr d theta first. Multiply that by sine theta, plus we need r, which was given to us, 1 plus 2 cosine theta times cosine theta. On the bottom now, negative 2 sine theta times cosine this time. Remember to subtract next. 1 plus 2 cosine theta, that's your r, multiply by sine theta. You could choose to try to simplify this, or you can go ahead and evaluate right now.